Good morning. As Murray mentioned earlier, my name is Gavin Kennedy. I'm the global head of the professional services team, and I've also brought some of the team out on stage with me today, and I'd like to introduce them to you. First, I'd like to introduce Peguy Pierre-Louis. He is the manager of our solution architect team. Sorry, now I'm covering you. Mayowa Ayodele, she is one of our solution architects, and Logan Lim is one of our quantum developers. They'll be presenting in a couple minutes some of the use cases that we've done with our customers recently and some of the results that we've gotten on two specific projects. But I want to start by giving you a little bit of an introduction into who the professional services team is. So we have three roles in the professional services team. The first is a solution architect. That is our main technical role within our projects. And they do an amazing job of understanding the customer's problem, understanding the data, understanding the constraints and the requirements that they bring to us in these use cases, and then turning them into a mathematical formulation to solve the problem. They work hand in hand with the second role on the slide, our quantum developers, to take those formulations and actually turn them into code that not only solves the problem, but does it by accessing our hybrid solvers, which you heard about yesterday, as well as the quantum computer. The third role that we have in the team are our engagement managers. So they are in charge of the management of the projects. They're in charge of the communications and the coordination with our customers. And they're in charge of making sure that those customers get the full business value out of the projects that they have brought to us. As you can see from the map on the right, we are based in North America, pretty much span the coasts of Canada as well as the United States. And we are based in multiple countries in Europe. We are excited that we are continuing to grow. So we're going to grow to keep up with the customer demand that we have right now, the demand for our services, as well as to broaden that footprint to where our customers are located. So as part of the launch program, the professional services team participates in the four types of projects that you see on the screen now. I'm going to start with the proof of concept project. Because it's the one that we strongly recommend that all new customers or all customers that are bringing new use cases to us, that they start with. In this proof of concept project, which lasts on average of about 6 months, we start by understanding your problem, having discussions with you to make sure that we know what we're doing and what type of problem that we're trying to solve. We then go through what I talked about with that model and that formulation and coming up with code that will be able to solve the problem. But it's in the testing phase where the proof of concept project really stands out. Because in this phase, we are testing with multiple data sets. And we are using the results from all of those multiple data sets, as well as results from benchmarking against other solvers, as well as the feedback that we're getting from our customers during all of this testing to take that solution and refine it so that when we are done with our proof of concept project, the solution that we're going to deliver to you is the best solution that we can come up with to not only solve your problem, based off of the data that you've given us, but also solve it in a way that we know that it's going to take full advantage of our solvers and our technology. Once we get those positive results, the professional services team is there to help support you as you move into the next phase, which is a production pilot. In this phase, you will take the deliverables that we give you, and you will start to build out your application. You'll start to build out your production application and integrate it into your systems, integrate it into your environment, integrate it with all of the data and tools that you need to run the system, as well as continue to test it with more production-like data. Once you have completed that project, again, the ultimate goal is to get this into production so that your company can see the full business value of the application that we have created. The fourth type of project, what I haven't explained yet, is the one all the way on the left, the proof of technology project. So very similar to the proof of concept, but it's a shorter duration. Where the proof of concepts average 6 months, this is more like a 3-month project. And the other difference is we go through the same methodology where we understand the problem and come up with a solution, but the major difference is we only test that solution on one data set. And we only really come up with an initial solution. This is used for customers who want to be able to see that we're able to solve their problem. Prove to them that the technology can work. Prove to them that the technology can come up with a solution. But it is only an initial solution. With that, you still need to proceed into the proof of concept portion of the project to make sure that we are, again, iterating back and forth and making sure that you get the best solution at the end of the project. I hinted at this earlier. No matter which type of project you pick, We do go through the same we go through the same methodology. We go through a problem design phase where we work with you to understand the problem, the requirements, and the data. And as you heard yesterday in the keynote speech, in this phase, you can either come to us with a problem that you know you want us to solve, or like we're doing with Boeing right now, you can come to us with a list of use cases, and we can help you decide on which one is best for starting with, and then do the other ones in the future. After we go through the design phase, again, we get into model and development, where we actually prepare the formulation and begin to build out a GUI, and you'll see some examples of those in a couple minutes. We then go through the normal phase of testing and wrap up the project by delivering some of the deliverables that we have scoped out in the statement of work and some of the examples that you see on the screen. I am now going to hand off to Pierre, and he's going to walk you through some of the use cases that we have done recently with our customers. Pierre?
Thank you, Gavin. All right, so all throughout this conference, you've been hearing from many of our customers and partners. And they've shared with you the many different problems and practical business problems that they're solving using our quantum and hybrid solvers. And I think by now, you can start to form an idea of the vast array of the very many different problems that can be solved, solutions in application that can be developed and supported using derivative technology. At the professional services, we work with very many customers, and with those customers, we help them build solutions and applications that cut across many different industries. And this is just an example of some of those. And by the way, this is not an exhaustive list by any chance. This is just the ones that we think we could spend a little bit of time and highlight to you today. So we have examples to supply chain and logistics, applications in manufacturing, solutions to AI and machine learning, defense industry, and the financial services. Under supply chain and logistics, a lot of these applications and problems, some of you can identify with them. One of them that I want to quickly highlight is employee and crew scheduling. And if you've spent any time at our demo booth out there, you might have seen the workforce scheduling, which is an example of that. Employee and crew scheduling falls under the general category of resources scheduling. So this is a problem that many businesses have at every level. As an example, if you have given employee relevant data such as availability, shift preferences, vacation time, skill sets, and given business requirements, we've worked with businesses to help them develop schedules that meet those business and operational requirements, but also minimize costs. Under AI and machine learning, we have a series of applications and solutions we've also worked with customers on, and one of them is feature selection. Feature selection is a very important step in training models in the machine learning applications workflow. Giving a large data set with possibly thousands, if not hundreds of thousands of features, it is extremely important to choose a subset of those features that are truly relevant to the learning task. This is important because that actually impacts computational costs. Choosing the key relevant features can help you reduce computational costs, but also improve the efficiency and accuracy of those models. Some of the customers that we've worked with as well have used feature selection in the context of developing solutions for fraud detection, as an example. In the financial services industry, we've worked with many businesses as well, and we have a list here of the different types of solutions and problems that we've worked on. And one that I will quickly highlight is portfolio optimization. We've worked with many banks and financial institutions in developing different types of solutions for portfolio optimization. And a lot of you are already familiar with that problem, but essentially, we're trying to build a portfolio which is profitable. So giving a set of different financial assets, as an example, that can be stocks or bonds, you're trying to build a portfolio that maximizes revenue or returns, but also minimizes risk. So there are two other use cases that I would like to spend a little bit more time on. One is in the defense industry, and the other is in manufacturing. And I will pass over to Logan, who is going to walk you through one example of an application we work with a customer on in the missile assignment interceptor a problem.
Thank you, Pierre. So I want to bring you through a single use case that we did for one of our projects. So if you've been following D-Wave for a long time, you may have heard of the interceptor assignment. So this is an extension of the interceptor assignment, and we're going to give you a sense of what we create for our customers in order to sort of sell them on the value of this application that we're developing in professional services. So the Advanced Missile Interceptor Assignment, I just want to give a brief overview. So imagine there's a number of missile threats that are coming in through a number of bases, and we have a bunch of friendly bases that want to intercept them with missiles. And these missiles can come out at a delay, and we want to make sure all of the targets are surviving with a very, very high probability. And after that, we want to make sure the costs are reduced as much as possible. So in order to do that, we created a model for this in one of our professional and services engagements, and then we created a GUI for it. So just to give you an example, this was the GUI we made for Davidson. So you'll notice that the PKIL that I mentioned before, the probability that a base can intercept one of these missiles is as this gradient over here, and those stars are sort of where the interceptors are attempting to hit the missile, and you can select the probability of survival, various solver parameters for this formulation, as well as statistics. So this is an example that something you could show to stakeholders to sort of convince them the value of this new quantum formulation, as opposed to giving them a spreadsheet that might be pretty inscrutable unless you've been spending like 3 months walking through the use case of this project. And just as another example, that demo that you saw from Alex yesterday, the Ford Otosan demo, it was originally part of a professional services engagement, and then someone from Alex Candela's team, the APG team, went and really upgraded it. So just to give you a sense of what your quantum application can look like, and sort of convince the stakeholders in your firms to adopt the quantum formulations. So now I'll hand it over to Mayowa.
Thank you, Logan. So the next use case we're going to be talking about is one from a pharmaceutical company. In this particular use case, it has to do with when we're trying to manufacture medicine, different kinds of medicine. For each medicine, there are different steps. And by steps, I mean things like encapsulation, weighing, sieving, coating. These steps can be different for different kinds of medicines. One major challenge is the fact that we have different machines that are applied to each step. For some steps, there are multiple machines. For other steps, there's just one big machine. So we need to be able to create this schedule where we avoid machine bottlenecks. Another challenge we had to handle is the fact that when we switch between medicines, say we were producing paracetamol, now we need to produce ibuprofen, we need to completely wash down the machines. Washing down the machine is expensive and it takes time. The third bullet point there has to do with the fact that different medicines requires different number of steps, and the steps must be in a predetermined order. So for instance, some medicines will need coating, while others will be in capsules, and different machines are required for different steps. The overall objective of this problem is to minimize the overall completion time, which we also refer to as the mix span. Another objective is to improve client satisfaction, because we want the medicines to be delivered on time. So there's a deadline attached to each medicine. Here is an example of a result we got at the end of this project. In black was the existing solution for this pharmaceutical company. In green is the solution we came up with at the end of the project. Each block represents tasks on a specific machine. Another objective that the client was trying to achieve was, if we look at some of the lines in the middle, those are weekend shifts. They wanted to be able to eliminate weekend shifts. But in order to meet deadlines in their current solution, they had to introduce these weekend shifts so that they can meet the deadlines. In our solution, we're able to make more efficient use of the machines, So we see that the green bars are closer to the start. We're able to improve the overall completion time by 64%. The client was very happy about this solution, and when our clients are happy, we're happy. Thank you very much.
So hopefully this gave you a little bit of an insight into the professional services team, who we are, what we do, and hopefully spark some ideas as to how we can help you become the next D-Wave customer to be quantum realized. Thank you very much.